Morning. From Tantra Foundation, we have myself, JRC, and Morrison here with Emeritus Professor Deepak Dhar, who has come from Pune to deliver the 26th SN Bose Memorial Lecture that happened yesterday. So, Professor, I mean, you are very well known in the circuit, a very renowned scientist, most sought after scientist here in India, and is the winner of the Boltzmann Award, which is the highest award given in statistical physics. So if
He's the only Indian
to get Boltzmann Award. So if I start with you, this memorial lecture is a continuity because the work of statistical physics you have put in, and SN Bose contribution, Meghnad Saha, you mentioned.
Yeah, right.
So if you can just tell our audience a little bit about this entire continuity and your work also in this context.
Okay, so I think it's I'm very happy to give this particular lecture about SN Bose Memorial Award, because SN Bose is amongst the pioneers in statistical physics, and his work is very profound and great. And there is a tradition of work in statistical physics in India, which I am kind of continuing at some level. And I guess so while it is technically correct that I am the first Boltzmann Award winner, but that's because people like Saha and Bose did their work before the award was instituted. So, and also, you know, this is statistical physics is one thing. There is another thing called statistics, which is a bigger subject, in which also there is a large number of Indian contributions. Mahalanobis in particular,
Yes.
Rao,
Yes.
Varadan, and so on. So, you know, there are a large number of people in this kind of subject from India.
And statistics is, I mean, the mathematical approach in statistics is very much deeply linked with the understanding of quantum physics as well.
Yes, of course.
Which is the fundamental development that took place.
Yeah.
So how, from a physicist's point of view, you see Satyam Bose being as a kind of a link between the understanding of Bohr and Planck and the new physics that came with, say, Paul Dirac and others, Heisenberg and Schrodinger.
Yeah.
Maybe.
So, of course, you know, my knowledge of history is not very strong point, but what I understand is that around 1930, when all this work was done, people were not very clear as to what was going on. They were making all kinds of guesses.
Yes.
So the formula which Bose derived was, of course, guessed by Planck, and he fitted some data to it. But they didn't understand where this formula comes from.
Okay.
And in the end, what happens is that you need a totally new way of counting, which now may look trivial, but at that time was revolutionary, if you might, theoretically revolutionary in a conceptual way.
Yeah.
And so that is the Bose's contribution, for which of course he is well appreciated. And so my own work has done mostly with classical statistical physics. So what happens if you take matter in bulk, then quite often you don't need quantum mechanics too much. You know, you should just accept that there are atoms which are stable for some reason or the other. In classical mechanics,
classical way of looking at it. Things.
Yeah. So it is a patch-up way. You take quantum mechanics to the degree that these atoms are stable. After that, I forget quantum mechanics, and I can think of nitrogen atoms as, or nitrogen molecules as, some rigid balls which collide with each other. That is the picture which Boltzmann developed, Boltzmann, Maxwell, and so on, which is actually quite correct. You know, it continues to be correct.
Correct.
In spite of quantum mechanics. Quantum mechanics provides some underpinnings for this picture, but it doesn't falsify it. So that is, so my work has been in classical statistical mechanics mostly, and dealing with the properties of bulk matter, you know, like sand grains.
You gave an example of a heap of sands.
Yeah.
I was going through that. And we have smaller particles of sand. We start with 1 grain of sand, we add 2 to it, and more we are adding sand to it, we are adding perturbation to it, right? And then it takes either a conical shape or it bursts into, you know, different patterns and holds something. So in a very prosaic terms, if you are trying to explain these two people who are interested in
Yeah.
science, because we want to make science popular now.
Of course. So let me just start by saying
Yes.
that while of course sand is a very familiar material,
Yes.
one should appreciate that it is actually somewhat surprising. For example, in some ways sand looks like liquid
Yes.
because you can pour sand from one bottle to another.
Yeah.
But in other ways it is like solid because you can make a pile and it stays there.
Yeah.
If you made a pile out of a liquid, it will collapse.
Collapse.
Right? So sand is neither solid nor liquid. It is some state which is different from both solid and liquid.
Interesting point.
Yeah. So this is well appreciated, but not by common people, because in classes we continue to teach
Says
there are three
solid.
states of matter,
Yes.
and everybody has seen that there is sand, and everybody has seen that the sand can be transferred from one bottle to another like a liquid, but they don't connect because there is the textbooks have a sanctity, and whatever we are taught we kind of continue to believe without thinking. But one should not unhesitatingly accept something which is just told to you and think for yourself for 2 minutes, and you will realize no, this is not fully true. So that is the point which is important to cultivate amongst young people. The other thing I would like to say is that the point about science is that we can add to the knowledge our ancestors have given us. So Newton was a very wise man. I am not as wise as Newton, but I can add to what Newton has said, and it might be actually correct, and I might actually in the end I might know more than Newton did, or I actually do know more than Newton did, because subsequently people have added to Newton's work, Bohr and Einstein and whoever, right? So we should not take the idea that there are some textbooks of religion or something which are the final word on our understanding, and if we try to do the opposite, then you constrain yourself and you cut off yourself from much of the progress in science.
And the thinking doesn't take place.
Thinking doesn't take place, and I am saying that people are actually sometimes schizophrenic. Sometimes they believe that these things are good, sometimes they believe these things are not good. So science and technology, everybody keeps on blaming them.
Yeah, there is
Well,
a kind of a bipolar attitude.
Yeah. So one should appreciate the fact that of course science is not always good. There are bad parts, but realize that this is the same thing. You can try to avoid the bad parts as much as possible.
Yes.
So I don't like to have too much plastic. I should try to reduce the amount of
Cut down on
plastic.
that.
But it doesn't follow from the same logic that all science is bad,
No.
which is what seems to be a popular mode of thinking. And the people who are very much anti-science and anti-technology are the people who cannot manage without mobile for 2 hours.
Yes. Yes,
That's a
and
very
also I would like
point.
to ask you what drives your curiosity even now, and how your journey in science went, because a lot of people should know more about
Okay.
your life and how
Yeah.
you started in this.
Okay, so I would say that there are very small points, but actually if you realize even this point, which is not original to me actually, it was pointed out by somebody else, that sand is not like liquid, not like solid, then you try to understand how does it behave, how does it flow. Does the flow of sand, when it does flow, is like the flow of liquid? The answer is no. So we understand somewhat well hydrodynamics, which is the flow of liquids. But the flow of sand is not understood even now. And it is technologically very important because we deal with granular matter in lot of work, everyday life, in medicine tablets, for example.
Salt, sugar, whatever we are
using, you
taking,
use
yeah.
them. And when you make medicines, in the end you make tablets which are made of powder.
Powders.
But powders have a very bad tendency that they sometimes unmix. So you have big grains and small grains, you shake them, they separate. If that happens to medicine, it will be very bad for you because some tablets will have too much of medicine, some will have too little. So we should learn to control and behave this behavior of matter and this requires study. And that is the kind of stuff which I have tried to understand. Not got there. I didn't actually manage to study the full separation of sand, but these are the processes which occur, which we want to understand, and then we try to understand them in some simplified way just now, because we cannot do the full thing. And so that is what I have tried to do. I have developed some simple models in which you can understand some of this behavior. Now it turns out that those simple models, one can actually use some abstract mathematics, group theory and stuff.
Like algebras and all those. No?
Yeah.
Something
Some algebra, group algebra it is called. It is not exactly Lie algebra, which is a specialized subpart. But the point is, there is some developed theory of mathematics which you can relate to understand the properties of sand. So I find this connection useful, and it helps even mathematicians who work in group theory may not always realize that you can understand the properties of everyday things like sand using group theory. So that is a point which I try to understand.
And because he's also the scientist who have got Padma Bhushan, I would just want to, if I go back from 70s, from Allahabad, you met you did your masters from IIT Kanpur,
yes,
right? And
yes.
then you went to California, California Institute of Technology.
Yes.
What was the broad area of your PhD research there on fractals or criticals?
Fractals and phase transitions.
Phase
So
transitions.
actually, I was the thesis had two parts. One was theory of melting, and the other was fractals.
Okay, and then you came back, I would understand, in 78.
Yes.
And then you were with Tata Institute of Fundamental Research, and where you stayed till 2016. And
Yes.
now you have moved to Pune, this Indian Institute of Education Research in Pune. So, Professor, just thinking about this small idea that you have worked on this biological growth also.
Yeah.
So this entire concept of fractals and the embedding of fractals, right? So we have a background, which is maybe this cosmos space-time, and there are certain particles or structures embedded in it.
Yes.
So there is a which is called the toroidal flow. There is a two-way information flow and reciprocation between the background and the structures taking place all the time. Information flow and energy, right? This is, I'm just trying to remember David Bohm over here.
Okay.
Okay. So so once this this entire system is perturbed, then evolutionary biologists would say that it would go to the next system where it gets the stability.
Yeah.
Is it something?
There is a sequence of
that's what I'm saying.
quasi-stable equilibria. Quasi-equilibria, which is what biologists use the term. So they see that for a while things are changing all the time,
Yes.
but they are kind of nearly constant. Then all of a sudden, in 1 million years, all the species die, or 80% of them die, and another ones take place. So those things are called new quasi-stationary state. And so there is a theory, people try to understand this. So they say there are punctuated equilibrium is the word they use.
Punctuated equilibrium.
Yeah, so there is kind of equilibrium in which things, then all of a sudden there is a big jump, and there is another equilibrium. So equilibrium states punctuated by sharp changes. Okay, now these kind of sharp changes also occur in things like earthquakes, because what happens is that there are these continental plates, and they move on the surface of Earth at the rate of 3 inches per century or some such thing, very slow. But they collide with each other, and their stress builds up, and then the stress is released in strong events like earthquakes.
And the mountains could be folds, or mountains could be the result of this.
Mountains are the results of the collisions of the
collisions
plates.
plates.
Yeah,
Yeah.
it's like the Himalayas.
Yeah.
happen.
Himalaya
Yes.
occurs
Yeah.
because of this,
Absolutely.
right? So people want to understand earthquakes, of course, because they are harmful to us, and these kinds of theories provide a general setting for understanding earthquakes. Then if you want to make a prediction about earthquake, which is what you really need, then you need more information, because these theories do not give geographical detail and all these kinds of stuff. So we do some work, and we leave some work for others. So for example, I've also worked in stock markets, the theory of stock markets.
Okay.
But my theory, whatever it is, will not help me make money in the stock market. Because what it makes you realize is that there is some understanding of how the stock market works.
Okay.
But forgetting all the details of the theory, in the end, some people will win, some people will lose. And if everybody has the same information, same knowledge of the theory, you cannot have an advantage over the other. So, stock market is like a game of poker. A lot of people play poker, some people win, some people lose. I have some theory that, 3 aces is more likely than 3 of hearts or some such thing.
Yeah.
But this theory can help me win if the other guy doesn't know all this. But otherwise it doesn't help me win. So people have the wrong idea that the only use of some theory like stock market theory is if you can make money in the stock market. Otherwise it is no use. No, it is like you can make money if the other guy is less informed than you. And that continues to be true.
Advantageous position then,
Yeah.
having more information.
So it is not just the theory helps.
Yes.
But only if you are ignorant of the theory, then you lose. If you don't, if you're not ignorant, then there is no particular advantage.
Right.
So that's a general
Yes.
sort of fact.
So we come to a last question. Now, how you see Indian education system, and because we are trying to also enrich, as you said, that wisdom is there, Newton is there. So, and there is this big, side of the Upanishads and the Vedas and the Tantra, which also talk about the holistic systems and perturbation theories and all these things, fractals. So how we are approaching this entire thing in this things are becoming interdisciplinary, and how to make these things available to science. In the West you find there is a popular they are trying to make science more popular, accessible to people by bringing in very common day-to-day experiences, like you said, the heap of sand or the salt, right? Whereas in India, if you see, we are still stuck to very academic discourses and within the university circuits, where we have to now come out and make these things, because this is our daily life. Science is all about daily life. It's not about the theories which are there in the books. So if you want to make a new progress, and you talk about stability of systems and punctured equilibrium, this is a very simple thing which is there in my cells. And if I go from scales to the cosmos and all these things, so it can give us some pattern of healthy systems, ecosystems.
Yes and no. The point is that, of course, some things survive to change of scale, and some things change. So, of course, there is grain of sand, but the mountain is not really a sand pile. So one has to appreciate that when you go to a different scale, some new emergent phenomena also come up. So I will not blindly apply the theory of cells and people to cosmos, because it is a very different kind of system. But some common phenomena may survive. So, for example, I suppose that the energy conservation continues to be valid at all scales. That is the best we know. I think the connection to Vedas, I will make some statement which is slightly provocative. I tried to say it in some other way before. I said that our ancestors, Purvaj, they were very wise people. But one should not take what they said as something written in stone. And they were very wise about something, they were wrong about some other things. And you don't want to take everything they said with equal confidence. And so we should be able to separate the good parts from the and I think
also
this
we can understand that things are evolving, like
systems are changing.
That's so, what I was saying, that in science we say that knowledge becomes bigger and bigger with time, or we have become better than 2000 years ago. In some parts of society, the feeling is that everything is encoded in some religious textbooks, be it Veda or Bible or Quran, and we don't need to know anything more. And I am saying that is actually obviously wrong, and it should be perceived as being wrong. And if some people believe this, that is because they were told as children that this is the way it is, and they didn't question. If you think for a few minutes, then you don't actually fully believe it. But sometimes when I talk to somebody else, I pretend that I do. So in my heart, I know I don't fully believe it, but talking to others, I pretend that I do. I'm saying that this kind of hypocrisy is not good for us,
Yes.
and we should avoid it.
Yes.
And
So-
also, I would just add, in this regard, I would say that it's very fortunate that you're from India, and also that in Hinduism, that liberty is given to
Yeah.
excavate further.
Precisely.
Whereas, Christianity and all is very
Very
close.
regimented,
yes.
very
Yeah.
regimented.
So Hinduism allows for science and for progress, and it's actually kind of not binding or holding. It's a very
Yeah.
progressive religion.
and,
I
and,
would
and
say.
very open text oriented. Openness is there, flexibility is
Yes.
there to explore, and that
So
is what
I
science
would
is all
say that
about.
it's actually very interesting. So this part,
Yes.
Yes.
there is a very enlightened part of Hinduism. But unfortunately, there is also a segment of society
Yes,
where is
which I
very
do agree, yes.
superstitious,
Narrow
and
parochial.
one has to distinguish.
Yes.
I mean, I don't want to say all Hinduism is great, because I know from my personal experience that some parts of it are not really
Making sense.
desirable. They make sense. Actually, what happened was that in the beginning, the key element which society wanted was stability.
Yes.
And I think Hinduism did provide stability to society. But we don't want stability, we want progress as well.
Yes.
And I think this is a very different word. And I think if you take very rigid views about what is written in various textbooks, then you are hindering progress. So I think whatever Darwin wrote is not written in Vedas. I think this part I am sure of. But I think he was also right. And it is wrong to exclude that from textbooks. So, that's what I
Yes.
feel.
And one last thing, since you brought in Darwin, now we are trying to look at this entire concept as rather than as a collaboration. If I look at the cosmos, and if I look at my cells and human body, there is a collaboration, information and energy exchange taking
Yes.
place, and that's how the stars and the universes operate.
Yeah.
So, in spite of, I can respect the differences between you and me, a mutual respect, and at the same point of time, we can now focus on the unity, because the
Yeah.
world needs some kind of a unity, because
Yeah.
we are talking about unified field
Yeah.
theory or
Yeah.
anything.
Yeah.
So, your parting question on that. Yeah,
Okay,
answer
I
on
would.
that.
I think this is a good point,
Yes.
and I would like to sort of disentangle a few parts in this.
Okay.
So, collaboration between people
Yes.
is one thing which we certainly want to encourage and develop. And collaboration between stars and cosmos is perhaps a different thing, and using the same word confuses the issue a bit. So I am saying that one should be quite clear that we want the human society in general to progress, and we should also be clear as to what progress means. So right now I will say that, okay, denying education to women is not progress, whichever textbook says.
Yeah.
Yes.
Right?
Yes.
So one should be aware of this, and one should fight against the bad elements of society as well, without shedding blood. We can convert them into our way of thinking. That is what I would like.
Yes.
And also,
And science can
just
help
the
in
last
doing
thing,
that.
how
Science
was,
is the way
your
to-
feeling to win this prestigious award, and also the Padma Bhushan.
So, but
And we are hoping that you would be the next person to win the Nobel Prize from India.
well,
probably
that
in
I don't know
physics.
about.
Yeah,
But
there is a
Padma
high
Bhushan, I would
possibility.
say I'm grateful for the honor, but it doesn't really help me change the society. It doesn't give me extra power.
Yes.
Okay, it gives me a little bit exposure, so
That's
whatever
very
I
beautiful.
say
That's a beautiful way of putting it.
I get a voice, but people have to listen to it. So in the end, the society has to accept the fact that this point of view is good. Now, that consensus in the society is hard to develop, and I'm not enough, I don't have intellectual strength or something to be able to do that. People like Gandhi they could bring about a change in society by making people think like them. I don't feel that I have that kind of influence, because I am sort of reclusive person. But I will do what I can. But I
You're
think
contributing in your
In your
own
own
way.
way.
We believe
in
that.
my own way, whichever I can, and I feel I cannot become socially active. directly working against all this, but I will do what I can,
Yes.
and it's for others to actually push forward and bring out the changes in society which are needed.
Yeah.
Let me just finish one
Yes.
thing.
Yes, please.
Definitely.
I feel that the education system in India is very bad, and I feel that we are betraying the younger generation by keeping it this way.
Okay.
If we find that the younger people in India are not well educated, it is not the fault of the younger people, it is the fault of the education system.
Yeah.
And the education system, you talk to anybody, we have talked to several people,
Yes.
they always blame somebody else. वो education minister ने ये कर दिया, मेरे principal ने ये कर दिया, मेरे teacher ने ये कर दिया, you can put the blame on somebody else, but in the end the blame is on us. So shifting blame from A to B doesn't help. Blaming Abul Kalam Azad for all the faults of the education system of India is not going to do any good.
The buck stops with me.
The buck stops with the society now. We have a democracy. We can elect the people who will do the change.
Changes.
Yes.
I'm not saying that the current government doesn't do it. I'm saying we cannot blame the government for
All the
faults
time. We have to take the
because we have
responsibility on
elected them.
ourselves. Yeah.
Yes.
Yeah. Absolutely.
Okay, so if you want some change, you tell the people in power that
Yes.
we want this change, then the change will happen.
Yes.
If people don't want the change, then it won't happen.
Yes. Absolutely.
Howsoever much I shout.
Yeah. Intention of change should be there in us.
Yeah.
Thank you.
I think
and
this
this is a
message
wonderful.
will go to YouTube and
yes.
probably make your voice heard to a lot of people who are aspiring to be someone like
Yes.
you, and encourage a lot of people, and especially Indians, to look up to a person
Science
like
research.
you. Yes.
Yes.
Thank
So
you very much.
Thank you,
Thank you
Mr.
for making this
Deepak
possible.
Yes.
Namaskar.
We
Yeah.
were very happy
Yeah.
to have you.
Namaskar.
Thank you, sir. Yeah.